Hello students, welcome back to Organic Chemverse YouTube channel. In this video I am going to explain some of the physical properties of alkane molecules. I have taken these two questions from reference book for NEET students by Balaji Publications. Let's get started with question number 49. Which compound has the highest boiling point? 2-methyl pentane, 2,3-dimethyl butane, 2,2-dimethyl butane and methane. Students, remember, as the number of carbons increases, the boiling point increases. Because as the number of carbons increases, the surface area of the molecule increases. As the surface area increases, the interaction between molecules increases, which is nothing but van der Waals forces. So due to increase in the van der Waals forces, the boiling point will also increase. Among the given options, methane is certainly not the answer because that is the one with the least number of carbon among the given options. But how to analyze option A, B and C? It's better to convert the UPAC names to structures. Students, remember, converting the names to structures is very important for competitive exams, and it's still better when you do it in terms of bond line structures. How to convert the names to bond line structures? Observe carefully. For 2-methyl pentane, there are 5 carbons. So pentane, right? At the second position, there is a methyl. In bond line structures, we write bonds as lines and we tend to omit the carbons and hydrogen. But it is indicated, it's obvious that they do exist, they are there. Now 2,3-dimethyl butane. So butane means there are 4 carbons and 2,3. Now 2,2-dimethyl butane and methane is not possible as I told earlier. But look at all these molecules, they all have 6 carbons in them. Then how to decide which has the highest boiling point? They are all structural isomers. And what are structural isomers? They have the same molecular formula but different structures. When we have isomers, the one with the more surface area will have higher boiling point. How do you decide the surface area? Lesser the branching, more the surface area. Here there are 2 more branches, right? Here there is only one branch. Therefore, lesser branching, more surface area, therefore highest boiling point among the given molecules. Hence the right option is option A. Let's move on to question number 50. Which cycloalkane has the greatest ring strain? Cyclopropane, cyclobutane, cyclopentane, cyclohexane. First, let's convert the names to structures. Cyclopropane, cyclobutane, cyclopentane and cyclohexane. What is ring strain? Ring strain is something to do with the bond angle in sp3 hybridized carbon and comparing it with the cyclic structures. In an alkane, the bond angle is 109.5 degree. That is for sp3 hybridized carbon. If there is a increase or decrease from this bond angle, then we call it as angle strain, distortion in the angle. For a cyclopropane, which looks like a triangle, the bond angle is 60 degree. which is highly deviated from 109.5 degree. More the deviation, more will be the ring strain. Therefore, the right option here is cyclopropane. However, cyclohexane is considered as least angle strain because the cyclohexane will undergo twisting of the molecule like this, and it will form a chair conformation where the bond angle will be 109.5 degree. Therefore, least angle strain, highest angle strain. Hence, for this question, cyclopropane has the greatest ring strain. I hope you have understood this concept. Thank you for watching this video.